Now we have one of the examples with the e. So you have y equal e to the power of 3x squared minus 5x plus 5. What is the y prime of this? Now let's say all this expression is u. So you have, what is the y? If y equals e to the power of u, then what is the y prime? Remember, we said e of x derivative equals e of x. Now, what is the y prime of e of u? Since you have an expression instead of u, in this case, then you need to have y prime not only equal e to the power of u, but equals e to the power of u multiplied by u prime, because you have a full expression. If you have only x, then if you have exactly e of x, then e of x prime equals e of x. But if you have e to the power of 2x plus 1x squared plus 5x cubed, whatever, then you need to take the derivative of the expression as well, multiplied by e of x, or by e of u in this case. So e of u by u prime, what is the u prime? If that's u, what is the u prime? U prime equals 6x, following the power rule, minus 5. Now e to the power of u, let's remove the u, bring it back as it was. So e to the power of x squared minus 5x plus 5. Okay, that's 1. Multiplied by the u prime we said equals 6x, in this case, minus 5. Then your final solution would be 6x minus 5 multiplied by e to the power of 3x squared minus 5x plus 5. One thing to mention, the author here have the derivative of u as 6x minus 5, same as what we had here and what we had here. Then when he reapplied that back down there in the equation, he had it as a plus sign, and I think that's a typo. Just something to keep in mind, because you see here, if you have u equals 3x squared minus 5x plus 5. Now what is the u prime? Now 3 stay the same, then x to the power of n, in this case 2, 3 by 2, x to the power of 2 minus 1, that's 1. Then minus 5 by x to the power of 1, that will be 1 minus 1 is 0. So you are left over with 5, and this one will go away as a constant. So you have 6x minus 5 as the u prime. And here you had e to the power of u by u prime. So that's a u prime. It should be minus, not a plus. Just something to keep in mind so that you will not get confused. So ignore whatever the author said here and follow this procedure of solution. If you have a function as the len of 2x squared plus 3x, what is the derivative of this expression? Now the derivative of len of x, so the len of x derivative equals 1 over x. Now what is the len of f of x derivative? This way it would be 1 over f of x multiplied by f of x prime based on the chain rule. Let's apply that here. So the len of 2x squared plus 3x, again, you can assume that as u, but I'm not going to. You can do that on your side. So that's 1 over the expression over the u, which is 2x squared plus 3x. In this case, we did the derivative of len of x, but we have len of f of x here. That's 1 over f of x, as it is, multiplied by the f prime of x, or the u prime in this case. Like whatever the derivative of this expression, that's 4x plus 3. Now your final solution, if you want to simplify it and make it more aesthetic, 4x plus 3 over 2x squared plus 3x, and that's your final solution. Sometimes you have things look very complicated at first, but they end up being solved easily, as we saw earlier. There's sometimes things look lovely, like this ln of x, but it takes some time. And some expressions with ln could take a while to be solved. So that's another confirmation that don't judge the book by its cover. Y equal the ln of cosine x squared. What is y equal the ln of cosine x squared? What is the y prime in this case? We said you can assume whatever inside the ln as a u and your life move forward. I'm not going to. Please go ahead and do it on your side. So I have ln of x derivative equals 1 over x. Ln of f of x equals 1 over f of x multiplied by f prime of x. 1 over cosine x squared, that's 1 over f of x multiplied by the derivative of f of x. So f prime of x, so in this case we have f of x as cosine x squared. Now that's a chain rule inside a chain rule. So you have the chain rule of ln of x as part of cosine, or the cosine being part of ln of x, and having the x as part of cosine. So that's a complicated or a compound chain rule. F prime of cosine x squared, that would give you, if you say that's g of u of x, then the derivative should be g prime of u of x multiplied by u prime of x. So f prime equals 2x multiplied by, what is the derivative of cosine x squared? That's minus sine x squared. Minus sine x squared. So the final derivative of the function f of x over here, minus x sine x squared. Now plug that in over here. So that's minus 2x sine the x squared. Okay, what is the y prime of that little stinky ln of cosine x squared? That seemed to be more complicated than it looks. That's minus 2x multiplied by sine the x squared over the cosine of x squared, and that's your final solution. Minus 2x sine the x squared over the cosine of x squared. The author is confirming that is the final solution as well for him. Okay, hopefully that is clearing out all the tips and tricks we went through as talking about the rules of derivative and how to find the fastest way to derive a certain function in front of you whenever you need it. We'll try to get more examples. Anything that worth mentioning, anything that we need to go through would for sure be presented in here to give you as much experience as possible about how to solve mathematical expressions. In this case, how to derive various types of expressions in calculus with the easiest way possible.